Hello guys, hope all of you are doing great. This is part 11 of our 8086 programming tutorial. In this part of the video, we are going to learn how to iterate over the characters present in a string. You know what is a string? A string is nothing but it is a collection of some characters. Now there are like many situations when you would like to iterate over the characters present in a string. Say for example, you want to write any one of these programs. Let's say for example, display the characters present in a string in different lines. No, in that case, what you have to do is the minimum thing that you need to do is you have to iterate over the characters present in the string one by one. Similarly, if you want to count how many numbers of characters are there in a string, then also you have to actually go through each and every character is present in that string. Say, for example, you want to change the case of the letters present in the string. So in that case also, say, for example, you just consider that string is iterating. So in that case, you want to convert, you want to now flip the cases. Say, for example, I is in capital, so you have to convert it to lowercase. T is in lowercase, you have to convert it to uppercase. So in that case also, the minimum thing that you need to do is you have to iterate over the characters present in the string. That is the minimum thing. And then in each iteration, what you do, that is specific to the program. So for example, if you're writing this program, then in each iteration, you might simply want to display the character along with a new line character at the beginning, say. Here, if you're counting, then here at each iteration, you might just want to increase the value of a particular counter. Here, you might have to actually check whether the character is uppercase or lowercase, and accordingly, you have to, switch the cases. But anyhow, that is the two things actually. The minimum thing is that you have to iterate over the characters one by one, and then in each iteration, you might want to do a program specific. You might want to apply a program specific logic, in each iteration. Okay. Similarly, check if a given string is palindrome or not. In this case, also basically you have to iterate over the characters present in the string, and then in each iteration, you might want to do some, you might want to apply some specific logic so that at the end of the program, you know somehow that whether the string is palindrome or not. Here, I'm assuming that you know what is the meaning of palindrome. Now, and again, these two programs also have that minimum requirement, sort of. If you want to write, like, count the number of words present in a string. So, for example, you consider this entire line is a string. So, in that case, how many words are there? 1, 2, 3, 4, 5, 6, and 7. There are 7 words there, and you want to count that. You want to write an 8086 program to count how many words are there in that string. So that is also a program, like that is also a program where if you want to write the program, minimum thing is or minimum thing is that you have to iterate over the characters. Similarly, if you want to know, like, check if a given string is a valid integer number or not. When I say if a given string is a valid string, in the sense I mean here, check if the given string represents a valid integer number or not. Either it is positive or negative. So anyhow, see here, these two programs I'm writing in red color. It means these two programs are the logic that you want to apply in each iteration is slightly complicated than the logic that you would like to apply here. For all these programs, these are very easy and straightforward programs. However, here they are slightly complicated, and in this part of the video, what I'm going to do is I'm going to write one or two of these simple programs, mainly showing you how you can iterate over the characters present in the string. Once that is done, then I'll give you some hints about these two programs, a small hints, okay? And then you people can try it by yourself. But later on, if you find them difficult, then you can let me know, like, if I should make a separate video on these two programs. Okay, so at the end of the video, I'll try to give you some hints about these two programs, what you might want to do actually. Okay, then let's begin. We'll start with this simple program: display the characters present in a string in different lines. Okay, let's begin then. I'll be opening this Visual Studio Code. Here is my skeleton of the program, and then I'll be writing the code. Okay, now before writing the code, let me explain you the program slightly. We know actually what we know until now is that, say, okay, let's start from here. We want to write which program? We want to write display the characters present in a string. Let's first fix which string we are talking about, okay? So say, for example, the string is stored in the data segment. Anyhow, the string should be stored in the data segment. The thing is, sometimes you might want to accept the string from the keyboard, from by the user. You might want the string to be entered. Or what you can do is, for simplicity, you can assume the string is already there in the data segment. Okay, so say, for example, I am declaring a variable string1, and then here I'm storing the string HELLOWORLD, and this is the end of the string. You might also want to so what you can add to the program is that, okay, the user enters the string from the keyboard and it is stored in this particular variable. How to accept a string from the keyboard, that I have not I have not said that thing in any video, but in my coming videos certainly you can expect it. But anyhow, if you want to know it by yourself, then you can just do a Google search and you will come to know. It is a very straightforward approach, just another use case of this int21h. But anyhow, for simplicity, I'm storing the string in the variable directly, hard-coded way. And then what we want to do is we want to iterate over the characters present in this particular string. Let's see here how the string is actually stored in the data segment. We know the string is stored in the data segment, no? So data segment, as you know, data segment is like some part of the memory. Suppose this is the part of the memory, like something is there before, something is there at the end, and here is the starting of the data segment. That is, DS register contains the first 16 bits of the actual physical address of this particular byte, that is the starting byte here. Say you just assume that is the say 712F. Okay, so that is the those are the first 16 bits of the data segment, and then these are the offsets, say 0, 1, 2, like that. What will be the offset of the last byte there in that particular segment? Yes, that's right. F, 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 F. These are again some other 16-bit numbers, 16 bits number. Okay, and you know already how to combine these two 16 bits number to get a single 20 bits number that actually represents the that represents the actual physical address of that particular byte. These I have covered in my videos like part 9 and 10. So please go through them if you have not yet seen them. Now, another thing that we know is when we write something like this here, string1 db hello world dollar symbol, what we know is that that string is going to be stored somewhere in the data segment, and all these bytes or all these characters are will be stored one after another in a consecutive way. Say, let's assume for simplicity that the string starts at memory location, say memory location say 9, okay, 9h. So here H will be stored. Similarly, at 10, it means A, it will be E, then B, it will be L, then L, O, space, like that. And then hello world, W will be stored like that. Okay, so that way, let me use this eraser for some time. Suppose I extend it for some time. Okay, I have some more space here. So hello world will be stored that way in the data segment, right? At some point of time, at some memory location, I mean at some byte number, say for example, say 25H, okay? There this RLD is stored. It might not be 25H, okay? If you follow one by one. But just for the sake of an explanation, I'm just saying you this thing. Now here, what is the point of interest is that the address of these, first thing is that all the bytes will be stored consecutively, one after another. After this hello world, obviously this dollar symbol, and one after another consecutive bytes. These characters will be stored in consecutive bytes. Okay, that is the first thing. And the second thing is that the starting address of this string, wherever the or whatever the byte number inside this DS data segment, that whatever the byte number of the first character of the string, in this case this 9h, is actually called as the starting address of that string. Starting, you'll be calling it as the starting address of that string, right? And you know already by this time that we have seen many examples of how to load the starting address to a particular register. So for example, if you want to display the string, the first string what we do is lea dx comma whatever the x of this string. This particular instruction, what does it do actually? It copies the starting address of the string str1 to dx register. So here, for in this diagram, according to this diagram, suppose what if we execute this particular instruction, what will be the value of dx register? It will be 9h. That is the starting address of the string. Up to this point, we know. Okay. Right. And then what is the next thing? That our goal is what actually? Our goal is that we have to iterate over the characters present in the string. So we know the value at the, now another thing that we have learned actually in part 8 and part 9. Say, suppose we want to see here, we want to know what character it is there in the memory location 9H. That is, say for example, what character, now we want to know what character is there at the memory location. When I say memory location, I'm talking about the logical address. It means I'm talking about the location inside I'm talking about the offset in the DS register. Okay, that is these numbers. Memory, what character is there at the memory location, say for example 20H. So this is the question that we have to answer actually. Okay. Now at 20H, say for example, this is 20H, and here say for example the character S is there. We want to know what character it is there at the memory location 20H here. That is the input or the information that we have is this thing, this 20H. What is the value that we want to know? Say for example, that character we want to copy, say copy that particular character to some registers for us, say for example DL register. Okay, to DL register. This is what suppose we want to do. Whatever it is the character at 20H location, that character we want to copy to DL register. Now, whether we know these things or not, see, we know that. Like last class, last video, maybe 9 or 10th video, we talked about the addressing mode, and you remember there is this base based indexed addressing mode, right? And what is the example? Like if you write something within the square, that is the first one. If you write within the square bracket, then whatever you write within that square bracket, that will be considered as the address of the memory location from where the data is to be retrieved. And these addresses we can write directly. We can write the value of those address, the value of that particular memory location. Or what we can do is we can write these addresses by making use of some registers. So here I mentioned like based index register. So how we can make use of this based index addressing mode to actually point to point to this particular 20H location. How we can do that? See here, based index, base address means, see, base means you can use any of the registers like BX or BP register. That is the base. Now from 9, and here what will be the base address? Base address will be actually the starting address of the string here. This is 9H. Okay, so what we can do is we can write here it in this way. So BX plus, we want to read the character whatever it is there in BX plus some number. See here, we BX is, say for example 9H, and then we want to retrieve the character which is there at 20H. With respect to BH, we can write this 20H actually, right? So now the question is, what is 20H minus 9H? Okay, that's I guess 20H means 32. 32, say 10. If it is 10, how much we have to add? 10 minus to 9. 10 minus 9, that is 1 we have to add. So if it is 20H, then 20H minus 9H, we have to add with 9H to get this 20H, right? So 20 is, I guess, 32. Let me confirm it just by making use of this calculator. Say from hexadecimal to decimal, hexadecimal value is 20, convert, it is 32. Okay. So where am I writing the, okay, I'm not, I'm writing it here, sorry. Yeah, 32 minus 9 is 9, so 9, so whatever it is, 32 minus 10 is 22, so this will be 23. Okay, so the value is 23. So 23 means 10, 11, sorry, 23 is in, it is in decimal actually. Again, we have to convert. If you want to convert it, you can convert it to hexadecimal. So just let me check. Decimal to hexadecimal 23. It will be 17 in hexadecimal. Most probably we are not using that concept here. But anyhow, the point is, you see, what we can do is based index addressing mode. So our goal is that this 28 we have to represent with respect to the starting address of the string. And we know how to get the starting address of the string just by making use of this LEA instruction. Here, instead of writing DX, you can write any register basically. I mean, yeah. And then what you can do is you can write these 28 or whatever that memory location you want to point to with respect to the starting address of the string, and that is how you can do this. So for example, the first thing you have to do is you have to load the effective address of the string to BX register of the string str1. You might be thinking, why BX? I mean, why cannot we use DX here? Can you use DX here? Certainly not, because you see, in addressing mode we learned, like whenever it is based index or based addressing mode, we actually use the base register, either BX or BP. We must have to use either BX or BP. We cannot use any other registers, right? So for that reason, DX is not going to work. So for that reason, we have to store actually the starting address of the string to BX register or maybe BP register. And then with respect to BX, now we can certainly write like this: BX plus 23 is the character which is there at location 28. So that way you can actually write. Now it is not based index addressing mode actually. Like if you write it in this way, it is not based index, right? It is simply based addressing mode. So based BX register plus some, some, what do you call that? Um, okay, some adjustment actually, BX plus some adjustment. Okay, here it is based addressing mode. But the thing is that suppose it is not the only one character that you want to actually access. What you want to do is you want to, from this memory location 9H, you want to actually iterate over, or you want to retrieve all these characters one at a time till you encounter these dollar symbol. So in that case, what you can do is, see here, this is just same. I mean, if you write somewhere BX plus 0, if I ask you what memory location it will be pointing to, it will be pointing to the memory location where H is stored. So if I ask you then, what is this? BX plus say 1. So you'll be saying, okay, it is actually, see here, this 0 BX means whatever it is, the starting address plus 0 means the same, plus 1 means the next byte here. So it will be E. Then the E means here, the BX plus 1 is your 9 plus 1, 10. 10 means A. And then the value which is there at memory location A is E. Similarly, if you want to retrieve the next characters, you will be writing BX plus 2. Then the next character, if you want to retrieve, you will be writing BX plus 3, like that. Now, if you see the pattern, basically what you're doing is you are writing BX. You can write this thing in general, BX plus. Now here actually what you can do is you can, again, as you know, in based index addressing mode, you are again, you have another space for writing a register here. Like you can write base register plus the one of the index register, and that's all. Like I can write in general all these expressions I can write in a general way, like bx plus si, where initial value of si equal to 0, and in each iteration we'll be increasing the value of si by 1. So si means si will be just adding 1 to this si. So that way initially it will be bx plus 0, then bx plus 1, then bx plus 2, like that. And when we are going to stop, yeah, whenever we encounter this special character dollar, then we'll be stopping it. And we know how to do that, right? We just have to see here. Suppose now we know like how to iterate over these how to actually access the conjugative characters. Once you know how to access the conjugative characters, then what you can do is you can copy them actually. Say for example, move to any register, say for example CH register, you are copying the content of the register BX plus SI. Based on the value of SI, it will actually point to some of these locations, and then from that location, whatever the character it is there, you are actually copying it to CH, say. And then you certainly can do like compare ch comma dollar symbol. Now, if it is true, then it is the end of the string. If it is not true, it is not the end of the string, isn't it? So these are the basic things that or basic concepts that we'll be using when we'll be writing the program. I mean, to display each character in a different line. The main point of interest is this based index usage of based index addressing mode here. Okay, we are going to write something like this to iterate over the characters present in the string. Okay, then let's now write the code directly. String 1 will be the string that we want to display, that we want to for on which we want to apply our operation. That is, of these strings, whatever the characters are there, we want to display them on separate lines. So first thing, let's iterate over the characters present in the string. So what is the first thing that we want to do? We want to make use of the source index register say. So for that reason, we'll be copying first to si the value 0h. Si is 0. And the next thing is we want in bx the starting address of the string. So we'll be writing load effective address to bx register of string 1. Done. Then what we want to do is we want to iterate over the characters. So this is how we're going to do it. So for example, for simplicity, I'm copying the first character. I'm copying the current character to CL register. What is the current character? The current character will be the character, whatever it is there, in the memory location BX plus SI, isn't it? So right now, based on the value of BX and SI, since SI is 0, so CL will be the first character present in the string here, H, isn't it? And then we will be comparing. Now compare the current character, compare the value of the CL register with we want to see if it is the last character present in the string or not. Compare CL with the character dollar, and then if they are equal, it means what? That is the end of the string. So jump on equal will be moving to, say for example, terminate. If it is equal, it means okay, that is the end of the string, done. Now if they are not equal, if the current character is not dollar, it means it's a character, it's a valid character or in between character in the string. So what we have to do is we have to display it on the screen. So first let's display the character on the screen. How do you do that? So to display a character on the screen, the first thing that we have to do is we have to copy the character to DL register. The current character is there in CL, so we have to copy the content of CL to DL register, and then we can then we have to store this special number in H register, and that is 0 to H. And after that, we simply can execute this instruction in 21H to activate the corresponding interrupt service routine, and that will actually display the character on the screen, whatever it is there in DL register. Okay, so that way it will print the character on the screen. Done. Now let's first execute up to this point, and then we will come to the point of displaying the character in a different line. So right now, if I execute this program, more or less I'll see the same string on the screen as an output. I guess you people know why, right? Okay, then let's now say my program is already saved. Let's now compile and execute the program. So I'm compiling the program and linking the program and executing the program. It is showing me H on the output screen, only the first character. Why is it so? You see here? Yeah, it is obviously, you know why. You compare, if they are equal, then you terminate. Otherwise, move to this point, display the character. And after displaying the character, I didn't make use of any loop, right? See, it just goes through this from top to bottom only for one iteration. So that is a mistake that I did, certainly. Now, what we want to do after displaying this character, what we want to do is we want our control to go back to read the next character here. But the thing is, to read the next character, what we have to do is we have to increase the value of this SI index, source index. Initially it was 0, so it will be now 1. Then we have to make use of this jump instruction to transfer our control to this particular point. So I'll be calling it, say for example, repeat, and put this semicolon here. Put the colon here. Done. So after this, after increasing the value of SI, we just want our control to go back to repeat. So that way, if I compile and execute the program, you should be able to see the entire string on this screen, right? Hello world. Here, see, actually, if you see the program, we are actually iterating over the characters present in the string, and we are displaying them separately. We are not displaying, it is like as a single string. The output is this hello world. Although it is hello world on the screen, you should realize that it is not actually hello world as a single string being displayed here. It is actually, age, and then just after that we are displaying e. That's why it is coming as if it is a string displayed here. But ultimately it is these individual characters are displayed. Okay, and how we can check them? Say for example here, every time we display the character, every time we display one character, along with that we also display one character randomly. I mean, what I mean is, after displaying the character, we actually want to display a space, say, okay, like this. So it means what we're doing is we display the current character on the screen, and then immediately after that we display this space on the screen. So that way, if you see now the output of the program, if I recompile the program and execute the program, then you can see this, okay, it is hello world, each and every characters are now separated. Now our question was we have to display it, on different lines. So in that case, what you can do is, as most probably I have said this thing in some of my videos. So in DL, you can actually store this number 10. That 10 represents new line character, line feed actually. Okay, so I'll be coming to this point. Just let me show you first the output of the program. You can store line feed in DL and then display that particular character. For 10, the equivalent display, the ASCII code is actually, ASCII character is actually the line feed character that represents the new line character. Let's see the output here first. And then you see here, it is hello world. Each and every characters are now displayed on different lines. That's what we wanted in our program, first of all, right? So we here, see here, the point is the minimum thing. How do we do that? We first set the index register, and then we load the starting address at bx register, that is the base register. And then in each iteration, we just copy the current character, whatever it is, the base register plus the current value of this, index register. See, bx never changes actually. Only thing that changes is this source index. And then we copy the current character to a, when I say bx never changes, means bx is not changing in this program. If you want, you can change bx, certainly. Okay, we'll be writing it in a moment. And then we are copying the current character. Now this part is actually, yeah, if it is the dollar symbol, then this is the end of the program. Otherwise, this part here, what you want to do in each iteration, this part will change from program to program. And at the end, certainly in most of the cases, you would like to increase the source index so that it points to the next character, and then you want to go back to, again to the beginning from where you copy the current character to CL and proceed further. Here, this part of the code is sort of program specific here, and the rest of these things are like from here, sort of, the default minimum work that, or default minimum program to iterate over the characters present in the string. Okay. What another thing here, I said that bx is not changing, but the thing is, this si, really is it important? You can actually write it in this way also. Directly copy the value which is pointed by this bx register, and then at the end, instead of increasing si, if you want, you can directly increase the value of this bx register also. So that way also the program should work. Here we are not making use of these si, okay? We are simply using this not based index addressing mode. We are simply using based addressing mode. Okay, so that way, if I now compile the program and execute the program, I should get exactly the same output. Sorry, that might not be the thing. Yeah, after that, yeah, we are getting exactly the same output, isn't it? So that's how we iterate over the characters present in the string. And then let's see what are the other programs. Display the characters in a string in different lines. Okay, count the number of characters in the string. You know how to do that. Change the cases of the letters in the string, upper to lower, lower to upper. Check if the given string is palindrome or not. Out of these, let me write change the case. Let me write this another simple program. Count the number of characters in a string. Okay, and these two I'll be leaving as exercise problem. You please try to write these programs completely by yourself, and then try to write these two programs. Okay, and these two programs I have to say something more, so I'll be coming to these two programs. Just let me first finish this another simple program. So here we have to count the number of characters present in the string. Okay, and how do we do that? It is simple, isn't it? Yes. In each iteration, instead of displaying the character or along with displaying the character, we also might want to increase the value of a counter. Now, how you're going to make it, which register you think you should be using as a counter? Yeah, since here we are using on this AH register is in use, I mean AX register is in use, DX certainly it is in use, and CX is also in use, BX is in use. So you can use, say, for example, move DI, destination index register, and there you copy 0. Or even this SI was there, no? We can make use of this SI itself. That is one way, or you can subtract the different ways are there. Yeah, don't get confused. So I'll be using this simple technique. In each iteration, dx compare cl, and then if it is this, terminate. Otherwise, just do this thing. And along with doing this, increasing dx, I'll also increase si. Okay, although we are not using si to retrieve the value of that particular character, or retrieve a particular character from a particular memory location, we are using si to actually count the number of characters present in the string. Initially started with 0. So here, if we want to, now there is a question here, how do I display the value of si on the screen? Yeah, that is something you have to know. I mean, it is now the question is same, how to display the value of a particular register on the screen. And as I said that I'll be doing it very soon and in the past also. So I promise in the next video will be on how to display the value of a particular register, whatever that value it is. If it is 192, that how to display that 192 on the screen. So that I'll be doing in the next video certainly. But right now, if you want to verify the correctness of your program, you have to actually execute the program in debug mode, and that way you'll be able to verify the output of the program. Okay, so but you just, if you think mentally, this approach will actually store the length of the string in this particular register si, right? Okay. Okay, then the next programs are count the number of words in a string and count the, okay, let me give you some small hints about these two programs, and that way that will be the end of the this part of the video. So count the number of words present in a string. Basically, what you have to do is the string, you see, I'm writing it now horizontally, but again, the same memory actually. Whatever the string it is, say for example, a cat is a dog. So these are separate characters. You can think in it in this way. It is. So each and every character has, and then this is the dollar symbol. Each and every character has this ASCII code. Now you have to, when we say that this is the end of a word, this is a word we know. And how do we know that these two are different words? Just by looking at this particular character. If it is a space, then we know that is the end of a word, isn't it? Now there are other situations also, like other characters also. Usually we consider them as the end of a word. So for example, here another string you consider a cat, comma, dog, comma. Usually when we write a comma, we also write a space actually. So that anyhow, the space itself is the delimiter. The word in this case will be cat, comma, and dog, comma. Is it the case? I mean, what my question is, you see, suppose there is this string, a cat, comma, space, and then a dog, comma, space, then a cow. Say it is written in this way, and I'm asking you how many words are there. As a human being, will be telling 1, 2, 3, 4, 5, 6 words are there. And what are the words? Those words will be a cat, a cow, I mean dog, and cow. We'll be not considering those commas actually, right? So those situations you have to take care of. how do you know, like, what are the characters that you will be using as the end of the string? Here, see, we are using actually this comma as the end of the string. This is a current string. I mean, logic I'll not tell you, but anyhow, just assume at some point of time your state was you were in a string. Here you were in a string, you were, oh sorry, you were in a word, you were in a word, you were in a word, but as soon as you read this character, you are not in the word anymore. Your word is over. So you have to actually, count. Okay, you have read another character, another word. Then this comma, since it is a comma, it is not, it can terminate the word, but it cannot represent the starting of the word. Now it is, next character is space. Since all you are not in any word, so it will not make any change in the state. Then it is a. Since already you were not in any word, now this is a valid character that can change the state again to a inward state. I'm saying in an abstract way, but if you understand that, then it should not be very difficult to write the program. Okay, and then you might be asking, like, okay, then that much only about the hints. You just try to write the program by yourself, and then if you find it difficult, I will try to help you. Okay, and the other question, like, whether a given string represents a valid integer number or not. The number could be either positive or negative. Say, for example, you have a string str1 where you have stored -123. Now, the output of this program should be, it is a valid number, yes, or the output of this program should be rather this way. It's a negative, sorry, directly write the word negative, negative number. Say in that string you store 123, then you will be stored, your output should be, it's a positive number. And say you store there, like, plus 123. In that case, you have to display positive number. Suppose you write there, the input string is, say, for example, plus minus 123. So that time you should display it's not a number. It's not a valid number, actually. Okay, if my spelling is wrong, just don't mind. And or suppose I write here the string as A23P. In this case also, this is not a valid number. If I write, say, A minus 23, say, in this case also it's not a valid number. Or say if I write 120 minus 3, this also should not be a valid number. Okay, so those are some possible inputs and outputs for your program. So it means what? At the beginning, the first character, if it is a negative symbol, then, and the rest of the numbers are valid numbers or valid digits, then it's a negative number. If here it is, don't get confused, like, I'm making the problem simple. Like, if it is, okay, if it is this, if you consider this thing as a, sorry, where was I? Here. If you consider this thing as a space, then the easier version of the program can say that it is not a valid number, not a valid number. Or what you think is, if you can write it, make it more efficient, then what you can think of is, okay, the trailing and the the spaces before the actual number, or maybe after the actual number, those will be automatically discarded. So that way it is a valid positive number. Okay, that is the another stage. Okay, but if that makes the program more difficult, then you can leave it. Like, if it is a space 123, you can consider it's not a valid number. The same way, like, say, plus minus 123 is not valid, or say, for example, a 123 is not a valid number. The same way, you can consider 123 with a space at the beginning. It's also a not a valid number. But if you can make it, certainly these spaces, like spaces at the beginning and spaces at the end, you can make it more efficient to make these a valid number. It is actually a valid number. Okay. So those are some possible inputs and outputs for program for the last program. So you just try these two programs by yourself, and let me know it in the comment section. Do you really want me to make a video on these two programs and write the programs for you, or can you solve it by yourself? Okay. But anyhow, those programs, if you do, then it will be certainly a good exercise for you people, programming exercise at least. Okay, guys, then that much only in this video. I'll be seeing you guys with some new content in the next video. Till then, have a nice day.